Welcome to the discussion, friends. This is a question from JEE Advanced 2024 and is of the topic magnetic fields, one of the amazing topics. The question says an infinitely long wire, infinitely long, located on the z axis, carrying a current I. Now, let's start off with the diagram. Say, for example, we have the z axis as this one, and let's say your x-axis is this, and let us take a y-axis along this direction. So this is plus x plus y direction, for example, and obviously the wire, long wire, infinitely long wire is on the z-axis. That means it's on the z-axis and carries a current of I. Produces a magnetic field B. Now, we know usually that the magnetic field that is created is in a, if let me show you, like if this is the wire carrying the current, the magnetic field is usually produced circular, in a circular path. The field lines, magnetic field lines exist in a circular path. That means suppose if you would experience a magnetic field around this wire, you would get it in a circular path of any radius. The B field would exist like this using the curl rule. Current in the direction of the thumb, or thumb in the direction of the current, and the curl of the fingers in the direction of the B field. Now here is the B field, and that means the B field can exist in a path which is circular in shape. Magnetic field B is used in this integral, and you need the magnitude of the line integral B dot dl along a straight line from this point to this point. Now this is an amazingly innovative question, very impressive. The magnetic field path being circular is being completely, you can say, escaped from this question, and the question is in fact asking you about a straight line path from a certain point to another, and the integral of B dot dl is to be targeted. It reminds us of the Ampere's law, but not useful here. It's not a bounded path, so Ampere's law is not applicable. Now let's target the points first. Now let us target the points first, and yes, the B field that we have has a value. In this case, if this has a radius of, let's say, r, then this will be equal to mu naught I by 2 pi r. We can derive this result using Ampere's law as well, like closed integral of B dot dl, B remaining fixed along a circular path. The integral of dl would be 2 pi r is equal to mu naught into current enclosed. So mu naught I is equal to B into 2 pi r. So that's why this magnetic field is of a long wire at a radial distance r. Now, where are the points? Let's say minus root 3a. So let this be the position of minus root 3a, and y value a. So let's say this is the y value of a, and this is the a distance till this point. So we draw a parallel to the y-axis over here, and let's make the y-axis parallel to this segment because of uh, the parallelism needed. Let's say this is your y-axis, this is the plus y-axis, and let's say this is the length of a. So we have this position as minus root 3a comma a comma 0. This point a is minus root 3a comma a comma 0. Then we proceed ahead and we go parallel, and this point is at a comma 0. So let's say this is the position of a on the x-axis, and we draw a parallel to the y-axis, and this point c is, let's say, again this length a, this length a, this length a. So a comma 0. And now the question is asking you to obtain integral of b dot dl along this path. This is what is needed. What is needed? The magnitude of the line integral B dot dl is needed along this path. Now the problem is the radial distance at any position, the radial distance from the wire is different. The R here and the R here and the R here are all different. But if I take two adjoining positions on the wire and if I call this length as a dl vector directed along the path from A towards C, then this dl length would be equal to r d theta. If I assume that, if you assume that this angle is d theta and this radial distance is r, this is equal to r d theta. And the magnetic field is obviously to be calculated along this path. And every time you will get a new magnetic field value, and that's the integral about. So at this point, in fact, at this position of let's say P, at point P, what is the value of B? The value of B or the magnetic field would be obviously perpendicular, perpendicular to the radial vector, and B vector would be equal to, given by this, mu naught I by 2 pi into R. At point of P, at point P, let's say this is happening. So therefore, this B dot dl dot product. Now vector B would be directed in the direction of the dl. So dot product would turn as simple B dl and it would be mu naught I by 2 pi r into r d theta, and that gives us mu naught I by r cancels, mu naught I by 2 pi into d theta, and that means integral of B dot dl would be integral of this entire thing would be integral of d theta now, because mu naught I by 2 pi is a constant, and theta, how does theta vary? Now here is the challenge of the question. The theta varies with respect to the orientation at point A, that is this line, and with respect to the point of C, that is this line. Let me redraw this line again through the point of P, just a moment. So A joined to origin through a straight line path can give you a path like this. Now, how much angle does OA make with the direction of the y-axis? With the direction of the y-axis. The angle that this makes, is very easily obtainable. See this much length is root 3a, like from this till this is simply root 3a from here till here, and this is a 90 degree, so a and root 3. So if I take this angle as some alpha, that alpha is tan alpha is equal to a by root 3a and 1 by root 3. Tan alpha equal to 1 by root 3 means this is 30 degree. So if this is 30 degree, obviously this remaining angle is 60 degree. So this is a 60 degree angle. Now again, this much length till here is a simple A. As you can see, this is A position, A, 0, position. So this particular A, and we have another length of A, and this is 90 degree. So this is a right angle with A and A. So therefore this angle is bound to be 45 degree, and therefore the remaining angle with the y-axis is bound to be a 45 degree. Now you see OA, let this origin be here, this OA, and OC make a total angle of 60 plus 45. So the initial angle, if I consider to the left side, I can consider that as a negative angle, and let me treat it like this. It begins from this position and goes towards this. This is 60 degree. So let's call this theta 1. So my initial angle is a theta 1 and the final angle is a theta 2. Theta 1 angle is this and theta 2 angle is this, and this is a negative angle. So here basically I will just note down just a moment. Theta 1 is equal to minus of 60 degree and theta 2 is equal to plus of a 45 degree. So mu naught I by 2 pi into effective theta 2 minus theta 1, and therefore I get mu naught I by 2 pi into theta 2, that is pi by 4, minus theta 1, that is minus pi by 3. You can make your guess. This is going to be a plus. So I can say mu naught I pi by 2 pi. So this effective pi goes off. This goes off. Mu naught I by 2. 1 by 4 plus 1 by 3, that's 7 by 12. That's 7 by 12. So we get the answer. This is the method, and this is our website. You can get all the details about us on this website, and this is a question of JEE Advanced. It took a little bit time to discuss the question, but the concept was simple. Application was detailed and difficult. Hope you enjoyed the discussion. Stay subscribed. See you in the next question. Thanks, and thanks for watching.